Well, hello, my name is Brian Madden, and I am one of the members of FAST Pinball, along with my colleagues Aaron, Dave, and Eli. Hello, and welcome to the FAST Pinball family. This video is an unboxing video. If this is for people who just bought one of the FAST Nano Controller starter bundles. And so I'm just gonna kind of walk through what's inside the box, how to get it hooked up, just like what does what, how you plug it in together, and how you can make some lights come on and check switches and that kind of stuff. So everything that's in this video is also online. If you go to docs, let me open the website here. Let's see, there's Safari. Docs.fastpinball.com. It says Fast Pinball technical documentation, and you can look at the menus here. I don't know when you're watching this video, right? So it might not be exactly the same layout, but if you look at tutorials and learning guides, for example, there is a connecting to your Nano Controller, which sort of walks you through what to do and how to get your Nano set up. This is the video version of that talk, by the way. So, by the way, in this the documentation website, as I said, and it's docs.fastpinball.com. You can go to fastpinball.com and click on documentation. Anyway, you get it. Let's just open the box and start taking a look at what's actually in here. So, a couple things. This is LEDs. So I think all of them come with this. This is like a 50 pack, 48 pack, 49, something like that of LEDs in here. We have the FAST Nano Controller itself and two other I/O boards, a FAST 3208 and a FAST 0804. And so let me kind of explain what these are and how these work. So the Nano is the main thing. This is our controller, and this plugs in USB into your computer, and then has these network jacks on it. And this network, it creates a loop network to our I/O boards. And actually, let me jump back on the website real quick and just show you here. If you look at the FAST Modern platform, which is what this is, and the overview of the FAST Modern platform, you can sort of see right here, we show the host computer. You see the host computer there, plugging in via USB into the Nano. That's what this thing is. And then you connect to the I/O boards, and these I/O boards are distributed throughout your pinball machine, and you plug the drivers, your solenoids or motors or magnets or whatever, and you plug your switches into these. So these boards, for example, let me find a pencil here. So like, for example, this board I'm holding here, this is a 3208. 32 means it's got 32 switches and 8 drivers. So you can know how many drivers it is because these big MOSFETs are there. So there's 8 of those. And then for the switches, you can kind of see, if I zoom in there, see it says like switch like 0 through 7, and then a couple grounds there. And then here's like switch, 8 through 15, 16 through 23, 24 through 31. So that's 32 switches and 8 drivers. This 0804 also is like the same board. Notice these boards, by the way, the driver boards are the same. Like if you look at like sort of like this side of the board, they're the same, right? And then it just depends on how many additional things they have, which changes the footprint a little bit. But this one, it's the 0804, you can see has 8 switches here, switch inputs 0 through 7, and then the 4 MOSFETs. So these two come in the starter kit. There's another board, a 1616, which has got 16 drivers and then 16 switches. So the idea is you can buy these driver boards, you can mix and match what you need in your machine. But the starter kit is going to come with an 0804, a 3208, which should be enough to kind of get you started and get your machine like flipping and that kind of stuff, at least your lower third and everything. And then comes with the Nano, the actual controller itself. So those are some of the things that are inside this box. You have the option to order the header pins also. So like here's for like 0804 Nano, the headers and the pins, these are where you make the connectors, where you actually like crimp these pins onto your wires and stick the wires inside these connectors. I'll show you one here. You're kind of making something like this for the connectors. You're plugging into your different boards. So, so you can order the headers and pins kits. By the way, going back to the website, and let's do tutorials and learning. And look at the skill building, there's crimping wire connectors. So Jacob Cord, who's one of our community members, who's a fellow pinball maker, wrote this guide, and we put it on our website that explains actually how to do the crimps and the tools you need and everything. We'll do a future video about that. But for now, if you order these header packs. By the way, these are stickers. Then you'll have those in your kit. So there's one starter bundle that is the controllers and the LEDs. Then you can also get the starter bundle that has power along with it. So if you do the power one, you're going to get 2 power supplies. One of these power supplies is 48 volts, and one of them is a combination of 5 volts and 12 volts. So the 48 volt power supply, so this has got actually like the line in from the AC power, like the high voltage AC 120 volts, and then it's got 48 volts, DC coming out of these screws here. And then same with this one. This is 5 volts and 12 volts, so it's got your AC power going in and ground, and then there's 5 volts coming out and 12 volts coming out. So 48 volts is what is powering the coils and magnets and that kind of stuff in your machine. 12 volts and 5 volts is powering the LEDs and the electronics and that kind of stuff. So if you order the bundle that includes power, you're going to get these 2 power supplies, and you're also going to get a power filter board right here. Oops, I got a fuzzy thing here. Pardon me. Okay. So the power filter board, let me do the close-up view here. This is sort of like your interface between your power supplies and the rest of your machine. So it has these plugs in here where you can plug in fuses. It's got these giant capacitors which you can use for high voltage lines to help keep the flippers have power. There's a lot of safety built into this board too. It's remotely disabled. So when you open the coin door, there's a switch input that goes on here that cuts off the high power so you don't get a shock when the machine's open or whatever. So if you bought the power bundle add-on, you're going to get this power filter board, and you're going to get these 2 power supplies as well. So that's sort of like everything that is available in that startup kit. So and by the way, maybe I said this before, this is for the Nano. If there's a different starter kit you have, make sure you watch the right video that was explaining something else. So okay, what's next? So let's actually like plug this thing in and like make it do something. So I'm going to kind of do some like magic of television here, where I'm going to take away these 3 things, and I'm going to show this, which is, we just call this like a power box, and this Aaron made. I'll do a future video. We have documentation again on the documentation website that shows you how to build this and kind of what we're looking at. But this is basically taking those. Let me get that out of there. Taking the 2 power supplies and the power filter board and the wiring, and like putting in like an AC plug and power switch and everything, and just kind of making it into one unit. So you can see like here, like the power comes in from the AC, and then it's kind of split and goes to the power supplies through the power filter board. It's got the fuses in there, and then it gives us this header which comes out and can plug into your Nano itself to actually power the Nano. So I'm going to set this sort of out of the way and go back to the Nano itself. It's kind of funny, the Nano and the 0804 sort of look the same, like they're the same footprint. I'll tend to grab them by mistake, like grab the wrong ones. You can tell that these are oriented differently, the plugs. But anyway, so the first thing to do for us is to actually plug in this Nano and like just make sure it powers up. Now, one thing we like to do, we sort of like stress, safety and not making dumb mistakes and that kind of thing. So the very first thing we're going to do before you hook up any power source to this, which by the way is a power source, you can build a power box. You can use a benchtop power supply, especially in this early phase when you're not even like really doing real stuff. You're just kind of plugging the board, just making a light turn on, just seeing the very basics. It sort of doesn't matter what you use for power supply, but I'm going to go ahead and I'll use this power box since we have it. So let me plug this in. Plug it in. I'm going to make sure that my leads are not like touching anything they shouldn't be. I'm going to power it on. And then I'm also going to power on my meter. And I just want to check and just make sure the voltages are where they should be. So if you look on the Nano itself, you see there's this power header. And you can see there's 2 12 volts, there's 2 5 volts, there's a ground, a key pin, and then a ground. And by the way, this is the same header that they used, like that Williams used back in the like WPC kind of era. So that's why we chose that header. You don't even necessarily need to have both 5 volts and both 12 volts connected. But I do want to take my power supply, which is on now, and that is plugged in, yes. Okay, my meter's on, so I'm just going to do my black to the ground, and then my positive to the red, and that's 5 volts, 5.00. Wow, that's actually pretty great. And I'm going to move on to 12 volts and 11.91. Close enough. Close enough is what matters. Especially these power supplies, when they're not loaded, can sometimes be sort of weird in terms of like voltages you get. So if it's like too high or too low, I mean, just make sure it's within like 10% or so. But yeah, that's a start. So anyway, power that off again. I'm going to plug into the Nano here. Oh, by the way, about these colors too. So like these are the same. Oh, it's funny, this wire actually just came out, but that is okay because there's 2 ground wires there, so I'm not going to worry about this at the time being. Let's kind of shove that back in there. Wire colors. So, there's no like, well, obviously you might be, who knows where you are in the world and what regulations you have around wiring and standards, like if it's National Electric Code here in the US. Since this pinball machine is like the inside of an appliance, there's not really hard and fast rules in most places around the wire colors, but we do standardize colors like within the sort of the FAST Pinball family. Actually, if you look at going back to this the documentation site on the how-to guide, so this is in the tutorials and learning section, we have a wiring guides section, and this wiring guide is got everything you need to know how to wire a pinball machine, starting at the beginning and crimping and basic knowledge, and then the specific how-to guides to step you through every single step. But I wanted to point out that here that we do have a pinball wire types, gauges, and colors. So like what type of gauge you need for wire, what type of wire, like stranded versus solid, not CCA, all that kind of stuff is explained in here. Also, we talk about wire colors in here, and these wire colors are not like necessarily hard and fast rules, but the idea is that we decide within Fast Pinball we're going to use these standard colors, and a lot of the colors are kind of arbitrary anyway. So if you pick these colors for your machine, then like all the pictures online, all the diagrams, everything matches. So we kind of recommend using these colors, but again, it's your pinball machine. One of the beauty of it is you can sort of do whatever you want. I should say also, anytime you're using high power, anytime you're using AC power, be very careful. Take everything we say with make sure you're comfortable with what you're doing. You have all your local codes, and don't, just make sure you know what you're doing with this sort of stuff. We're providing this guide, but I want to make sure I don't say anything that becomes, that becomes an issue. So just make sure that, make sure you feel comfortable doing wiring and that kind of stuff before you get started when high voltage is involved. But anyway, so now I have this, I'm plugged in. I'm going to turn on the thing, and it's hard to really see. A little light there came on for a second, and now we see there's a light here that says power. That light is on, and then I've got a flashing light down here. That's actually for the processor that runs the LEDs. But that means like, okay, great, this is awake. End of video. First step done. Go have a beer. Now let's actually hook this up to the computer because the way the Fast Pinball modern platform works is your game code actually runs on a computer. Now it doesn't have to be like a big desktop computer. It can be a Raspberry Pi. It can be a Mac, Linux. It can be whatever you want. You can write it in any language you want, but the code that runs your machine runs on a computer, and that machine plugs in USB and talks to the controller, such as the Nano, and it sends commands back and forth. So it sends commands like turn this light on, fire this driver, or when a switch in the machine changes, the Nano reports that to the computer so that the computer can take action. So the first step for this is USB. So this is just plugging in via this is a USB mini connector. We use minis instead of micros because they're a little bit more robust, and so that goes in there. And that's pretty much it. So now just put a piece of tape on there. Okay, so now we're on the computer. So let me actually flip over back to the computer here. And I'm going to open up an application that's called CoolTerm. And so CoolTerm, it's a free app. This is Mac, by the way. I'll show you Windows in a second. Where do I go? I'll show you Windows in a little bit. But you can connect to the FAST controller directly from your computer and send it commands, like manually, like typing in commands and sending it in. It's cool. Now, it's probably not how your machine's actually going to work because you might be using something like the Mission Pinball framework, or you might write your own framework in whatever game game code you want or game platform you want. I mean, you can, that's the beauty with the FAST controllers is there's no drivers, there's no software libraries. It's just these serial commands that go back and forth over the over this USB. So if I go back into the computer here, and so this is CoolTerm. So I've opened up this CoolTerm application, and I want to click on Options. And this again, I'm showing on a Mac. CoolTerm also, it's the same on Windows. And by the way, you can use whatever terminal emulator you want, if you, like PuTTY or it doesn't matter. There's lots of different sort of terminal emulators. But if you don't know what a terminal emulator is and you don't know these words at all, look up CoolTerm, find CoolTerm, download it, install it. When I click Options, so this CoolTerm allows me to connect to devices. So where it says serial port, I'm gonna click this rescan serial ports button. And I don't know why, oh, you know what, I'm connected. That's why I can't do that. Let me just disconnect there real fast. I had left it connected from last time. Okay, so now where it says port right here, see there's 4 ports that say USB serial. And what's funny is there's 4 of them. They're in numeric order, but notice the order there on the screen being reported is not like the lowest numeric order. So it's 0, 1, 2, 3. And so here we can select which port we want to connect to. So I want to connect to the second port on the list. So this one, the first one is this by lowest number. The first one's 0, then this is the second one, third, fourth. So the second one is this 1 right here. Baud rate, I'm going to connect at 921/600. By the way, when you first get the software, you probably aren't going to have that 921/600. You can click this little custom button right there and enter a custom baud rate. So you want data bits 8, none, 1, that's all fine. I also want to click on this terminal screen, and where it says enter key emulation, I want CR. That means a carriage return. It's just what happened when you push enter. It sends a CR command. And I want local echo checked, which means when I type a key, then it shows up on my computer right here. So this might not mean a lot to you right now. It kind of doesn't matter. Let me get this back down here. Just do those settings. And when you do that, so when you put those settings, I can click the connect button. And now, okay, I'm connected. Now what's happened? Nothing. Look down here, it says connected. I can see there's some lights that are on. But nothing really happens. If I hit enter a few times, okay, I get XX, turn this down a bit, I get XX:F. And that's actually the FAST controller talking back to us saying that last command failed. And it's because if I just click enter, there's no command, I'm just hitting enter. So let me show you what we can do here. I'm gonna type ID, like letter I, letter D, colon, and then hit enter. Boom. There we go. ID net FPU-CPU-002-2 1.05. So that is showing that I've made a connection to the net processor on this board, and it's given the serial number, or not the serial number, the product number of the board is connected to, and it's telling me the firmware version that is on that board. It is 1.05. So that's it. I'm connected right now to this board. Now, if you didn't get this, like I said, if you get, any command you enter that's not recognized is going to come back with that XX:F. So if I type hello, enter, that's not a real command. If I type blah, 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 that's not a real command. But ID:, enter, is a real command. Yeah, I can do things like, I can do a CN command, a sense for configured nodes, and then push enter. Node configuration, node name, version, etc. Now the nodes, that's the node boards. That's these I/O boards that will be connected to the machine. There are no I/O boards connected right now, right? Because we have just this. It's just the Nano by itself without anything plugged into it. So that's why it shows nothing. But you can send these little commands and actually talk to the board. So I think what I want to do now is actually plug in some of these other I/O boards so that we can do a little bit more than we just did by showing the ID and nothing. To do that, by the way, so you can also order in your starter kits, you can order Ethernet cables. These are regular Ethernet cables, regular Cat5 with RJ45 ends on them. So there's nothing super fancy about these. We have them because We like these ones that are flat and they're included in the kit, but if you have your own cables, use your own cables. I mean, there's really nothing sort of too fancy about that. So let me get these opened. And what we do with these, I'll go ahead and turn the power off here. By the way, when I turn the power off, let me go back to that Mac. You see down here, it says disconnected now because I powered off the board. So of course it's like it disconnected. So the way these work, so you notice that all of the fast boards have these RJ45, like Ethernet. No, they're not Ethernet. They are not Ethernet. They are not Ethernet. They look like Ethernet. It's the Ethernet style connectors, but this is not a computer Ethernet network. Do not plug this into the network port on your computer. Do not plug this into your home router. We have made sure it's not going to like damage it, but it's not going to function because it's not Ethernet. But what happens is the way this board works is if you look at this Nano, you see that it says in with an arrow. Oops, what if I do that? So here it says, where are we? In, and then here it says out. So this is the in port and this is the out port. And then on each of these I/O boards, you also have like in and out. So all we have to do is connect them in a loop, essentially. We actually call this a fast loop network. So I'm going to connect, let's see if I do a little bit of zip tying here. So I'm going to connect this is the Nano, so I connect out from the Nano to the in of one of my I/O boards. Then I'm going to take the next one, and I'm going to plug out from this I/O board to in of this I/O board. And then one more. So we have to close this connection as a loop, right? Like you don't want to leave it as this right now. Let's see if I can fit these all on the screen. There we go. You don't want to leave it like now it goes from Nano out, in, and then we need to close the connection. And so I'll do this last out right here, goes to the in of the Nano. Okay. And so these boards can be connected in any order, although it numbers the switches and the drivers in the order based on the boards are connected. So like I connected the 0804 first, so this is going to be drivers number, well, it starts with 0. So 0, 1, 2, 3, the drivers, and the drivers 4, 5, 6, 7, 8, 9, 10, 11 are on this board. Switches 0 through 7 are here, then 8 through 15, et cetera, et cetera. So that's how everything gets numbered and sort of how it works. So I have these now connected. Now, what's interesting is I can power this back on, and we're going to see some lights come up. So we see that link light comes on. Nope, you don't see that. Let me do it right here and lift this up. I don't know if you can see that. It's kind of bright in here, but there's a link light is on solid, and then the status light is flashing really fast. And then same with this one. If you can see, link light is on, status light is flashing really quickly. So this loop network in here delivers it's actually 12 volts that these boards are running on. This delivers the power via these network cables to power the actual I/O boards themselves, and to power the switches also. Now drivers that are high voltage, those are powered separately, but the actual boards themselves, there's no power to power the boards, if that makes sense. So I've got now a functioning loop network right here. By the way, the fact that the status light is flashing very quickly, that's telling us that these boards are in lockdown mode. They do not fire any drivers until you enable a watchdog, which is a separate command. I'll get to that in a little bit. Actually, we probably won't cover that in this video, but as safety, it's not going to fire any high current stuff until you specifically enable it and tell it that it's ready to go. So that's why we have these super fast flashing here. What I want to show is, I'm going to go back to the computer here. So a couple of things. So first of all, look, it connected again by itself, because remember I had like left this on and just powered off the fast board and then it disconnected. Well, since the software on the computer was already running and kind of waiting for the connection, it was just waiting to connect again, and it did. Now, when the board powered back on, you know, it connected back in the computer. Now you might notice that there's these weird characters like upside down question mark, blah, blah. What is that stuff? That's just kind of like garbage on the line because we had this thing plugged in and connected as the fast board turned on, and it, you know, whatever like random logic levels were there, just kind of garbage data. You see that at the end of this, you see where it says B, there's an exclamation mark B:02. That's actually the command that the board sends to the computer telling us that the boot is successful. So anyway, but I can hit enter a few more times. Remember, enter is always gonna be fail because like it's not a real command. But I can go back to my commands I learned before, ID, enter, blink. And there's the ID of the board I'm connected to. Now remember, configured nodes shows how many of these node boards, these IO boards are connected. I'm gonna do CN:, enter. Hey, look at that. So now board 0 is showing that it's you know, here's the part number. It's it's the 0804, right? And it's running firmware 1.05. It has 8 switches. It has 4 drivers. These are extra data for data in and data out, which is not really used anymore. Now that we have the fast expansion bus, not a topic for today, for today's video at least, but just you can sort of ignore those. And then there's a serial number of that actual board, like the actual board serial number itself. So the first board, the first node we're connected to is this 0804. Now we can see the second one we're connected to is that 3208. It's also running version 1.05 of the firmware, and you know, 20. Well, actually, I should point out. I'm saying 20 switches. These values are in hex. So anytime you're less than 9, it's the same as decimal. But then 10 is not 10; it's A, and then 11 is B, etc. So 20 switches is really 20 is 20 hex, which is 32 switches in decimal. So anyway, so I see the nodes here is the point. So you plugged in the node boards. I can see the nodes, and they're looking good. That's cool. Let's do something with them. I wonder if I have, I'm looking for a wire here. Whoops. Oh, I can use this. Okay. I'm gonna use this little jumper wire here, it's just one of these like little, can you see these things? There you go, like these alligator clips. This is just a one wire with these clips on both ends. Check this out. I'm gonna operate a switch right now, and we're gonna see the switch report on the computer. So in order to do that, I'm gonna zoom in here. Make sure those boards don't touch. Okay, do we see where it says switches? Like switch 0, 1, 2, 3, 4, 5. And then G and G is ground and ground. So I'm gonna hook this onto one ground. And now I'm just gonna touch switch 0 just for a second. Touch it and then lift off. And what happened here? If I go back to the computer, do you see where it says there's a -N:08, and then there's a /N:08. That's showing us that this switch was activated and then deactivated again. Because remember, in pinball machines, like whenever a switch changes state, that's the action. So the switch closing is like the first message. The switch opening is the second message. And I'm gonna leave the screen on the computer here. I'm gonna touch the switch again. So I'm gonna touch switch 0, and hey, look at that, and then like release. Touch, release, touch, release, touch, release, touch, release. But look at, there's switch 0, 1, 2, 3, 4, 5. I'm gonna take this little thing right here and run it down, right? Like I just have this open, and I'm just gonna run it right down the row of switches. And now if I go back to my Mac, look at all that switch activity, right? I'll do it while it's on. Right? So you see all these individual messages of the switches opening and closing. And look at the numbers, by the way. 8, 9, A, B, C, D, E, F. Remember, these node boards are in order. So this 0804 has 8 switches on it. So the first switches, switch 0s through 7, are on this board. Then the next 32 switches are on this board. If you had a 1616, the next 16 switches are on those boards. So you'll see how it works, right? The switches are just numbered sequentially. The drivers are numbered sequentially. But that's cool. So now I'm seeing switch activity. Yeah, that's great. What else do I want to do on this thing? I think let's do some lights. Yeah, let's do some LEDs. And then the drivers I think we'll do in a separate video, because drivers, where you fire a coil or like have a switch to hook up a flipper or whatever, that requires high voltage. And I want to do high voltage like properly on a playfield, like on a whitewood. I don't want to just have like all these things everywhere and like wires flailing around and have high voltage on here. So for this video, I'm just gonna say, hey, our boards are up. We can see the boards reporting. We have switch activity coming in. So that's all cool. So I think what I want to do now is like I said, go to the, let's do some LEDs. So for the LEDs, this is interesting. I'm gonna go back to the computer here because if I go to Safari and go back to this Fast Pinball documentation website, you can click on the product manuals on here. And then for the product manuals, let me get out of the way. For the product manuals, you can see like, here's our platform controllers, IO boards, yada, yada, yada. So I'm gonna click on the Nano Controller since that's what this video is about. And then here's our documentation for the Nano. And one of the things you can see is the serial interface. We talk about how there's 4 ports on here. Like remember when I went into that software and it had 4 ports listed? Oh, that's a good, yeah, that's a great troubleshooting thing, which I should maybe back up and say, if I go to this software, I'm going to disconnect. Put myself back in here. So this is that CoolTerm software. If I disconnect from CoolTerm and go to options, remember for serial port, I said pick the second port on the list. This is again the second numerically. So these are, by the way, the name and numbers here are like kind of random. In fact, if I plug into a different USB port, it might be different. Different operating systems work differently. On Windows, they're going to be COM1, COM3, COM7, whatever it's going to be. So you can see there's the ports, the lowest one, then second, then third, then fourth. So I connected to the second one to get to that net processor, and that net processor was a processor on this on the Nano, which talks to these boards. Well, if you go into the documentation, you can see for the get off here. You can see for that Nano product details, hey, there's 4 serial ports, because when you plug in the Nano to your computer, you'll see those 4 ports appear. And what are these 4 ports for? So there's port 1, not used, port 2 is net, port 3 is RGB, which is for LEDs, and port 4 is not used. By the way, when we're saying these ports are not used, another thing I'll say is that you may have read, and you can see on the documentation page, we have some sort of new ways of working with like servos and steppers and LEDs and other like little driver control things, which is called the fast expansion bus, and like our retro controllers, which I think there's a System 11 controller in Fire, there's a System WPC 89 in Roadshow. All of our retro controllers have this expansion bus and display bus. The Nano, which is here, has the ability to use those new buses too, where there's this little hat that we have. And so the hat, you see this has got these plugs in it. And then on the Nano itself, there's various like headers. So you can actually plug this in. And I don't want to do it while it's on maybe, but I have another one with it plugged in already. Look at that, like a baking show. And so now it's kind of cool because this thing, it keeps it obviously you can still get all the plugs you need to. It sort of wraps around the existing plugs. So the Nano with this hat on it is how you add the display bus and these expansion buses to the existing Nano. And by the way, when you do that, that's where you use these extra ports. So if I go back to this Mac here and I talk about, the Nano without the hat, the second port is the network port, the third port is the RGB LED port. When you plug the hat in, those additional ports are used for the expansion bus and the display bus. But again, like different video, different instructions, different, you don't have to worry about that at this exact second right now. But I do want to show though, turning on some LEDs. And so to do that, we need to connect to a different processor. So what happens is there's multiple ARM processors, well, not ARM necessarily, there's multiple processors on the Nano. And they like sort of do different things. And as a matter of fact, even within the fast world, even these IO boards have processors. There's microprocessors on them. So the more boards you add to your environment, it doesn't slow things down. It adds more processing power too. So they can just be very efficient in terms of like speed and responsiveness and things like that. But so anyway, there's a concept of you're connecting to these different processors. So I want to go into show you RGB LEDs so that we can see here that's on port 3. the third port, I should say, on that list of ports. And so if I go to, what am I doing? Let me go back here. So remember, okay, so the first port, I want to show, first of all, by the way, if you connect to a port that has nothing connected to it, like that first port, just say OK. And now I'm going to click connect. And I click connect and I hit enter, but like nothing happens. Remember before when I hit enter, it was XX:F because just a blank command, it's not a real command. But now there's no response because literally that first port has nothing connected to it. If I had plugged in this little hat and then plugged it into one of our expansion boards or one of our display boards, then that board processor would be responding right here. But since it's not connected, it's just like Aaron says, it's shouting down the hallway that's empty. So I'm going to disconnect. I'm going to connect to the third port. And again, third port is not the number 3, it's the order of lowest, because these are called 14, 300, 301, 302, 303. They could be random, different numbers altogether on yours, right? And if it's Windows, it might be COM 5, 6, 7, 8, you know, it's completely different. So I'm just gonna go in order to the third one right there. And I'm gonna just click OK. And now I'll click this little clear data. Oops, you're not even looking at what I'm doing here. Let me show you that again. I'll go to options here and just show that I'm connecting to the third port in the list. So there we go. There we go. I'm going to click on clear data right here just to clear off the screen. And I'm going to click the connect button. Hey, we connected. Again, there's like some rando garbage on the screen. It was probably, since this is the first time we connected to this processor since we powered it on, that was like what was in the buffer, whatever, that's fine. Enter a few times. XX:N. A little bit different message, but still a message telling us that like that's not a real command because it's enter. But again, what can we do here? We can do ID. ID:\enter. And what do we see here? It is RGB, so that's the RGB LED processor. It's the same board. And then it's firmware version 1.0. You'll see on the website, and if you go on that products page, you can see what the current firmware is or what the latest firmware is. I can do another video on the firmware updates as well. Oop, my camera just turned off. It's a close-up camera. I guess it doesn't matter. There we go. All right, there we go. What was I saying? Oh, anyway, so there might be different versions of firmware for different processors, right? That's why this is version 1.0. But anyway, we are now connected to the LED processor. So in order to do something with the LED processor, we should do something with the LEDs. Now, let's talk about LEDs. Actually, do I want to make this a separate video? Yeah. No, it doesn't matter. We'll roll through this. Let's just do a starter on LEDs. So first of all, if in your starter kit, you might get this board of LEDs. Okay. I don't remember. I have to ask Aaron. So these are individual LED modules that you would put under your playfield. I have one here. So like you break them apart, right? Like you break off. Actually, I'll show you like this. Here's one I started kind of like breaking apart. So break that off, and then these all just kind of come apart. By the way, these are not connected electrically, so keeping them together does not mean these will all like run without wires. And so the idea with these little LED chips, if you can see this, is this component right here. That is not the right view. Nope. Let's see, there we go. All right, it's my first video here. So that little chip right there is the actual LED. It's got a red element, a green, and a blue, and there's a little processor in it. And then you see here, there's these holes in this little board where it's ground, it's 5 volts, and the middle one is data. And then you see on the bottom, you can either solder directly to these pads here, or you can like plug in a header and solder that header on. If you do this, like I said, if you are soldering the headers on these boards, it's way easier to do them like all at once. So you take all your little headers and like set them on the table and kind of like set your board on top of it, and then just like solder all of them instead of trying to do like one by one by one. It takes a little while. But anyway, so the way that these are all serial LEDs. And what that means is that you can have a long chain of LEDs. And on the Nano, for example, it uses a WS2812 family of LEDs. They only have 3 wires. So we have one wire, which is voltage, 5 volts. The other wire, which is ground. then the middle wire is the data or the signal wire, and that actually pulses like binary data, like codes. And every LED in the chain knows where it is in the chain, and so it will only listen to the instructions for itself. So it'll be like first LED, red 12%, blue 15%, green 100%, second LED, red 12%, blue 19%, third LED off. Like it's just broadcasting that down the wire, and all the LEDs are turning all their colors based on only having a single data line like going down the whole thing. So, and that's why these have in and out. So if you look at this close up here, you see like there's the arrow showing here's the inside, the side for the in, 5 volts in, data in, ground in, and then the other side is 5 volts out, data out, and ground out. So if I go back to my, here's what I'm gonna do. I'm gonna disconnect these boards just because I don't need these I/O boards right now. I'm doing it while it's on, which the system will actually figure out, so that's fine. Okay, so I've got the Nano up here. I want to show you on this. Now we're looking this kind of upside down. I'll flip this around. So here's the RGB LED connectors: channel 1, channel 2, channel 3, channel 4. You see there, you see ground. That looks like DO. That stands for data 0, and then, or data out, I mean, and then 5 volts. So like ground, data out, 5 volts, ground. So you have on the Nano, these individual channels can each support up to 64 LEDs in a chain. So you can have a chain of 64 LEDs. Let me just, how can I do this here? Put that there. I'll throw some tape over it to kind of hold it. Okay, so we can have a chain of up to 64 LEDs on the Nano. I'm gonna do just one right now. So like here's this, I have these little jumper cables. You can buy these on Amazon. Can you see the ends on there? They're like, I can't reach them. They come in these big packs. You like kind of rip them apart, and so I plugged one side in here. We use, if you refer to our wire coloring stuff, 5 volts red, ground is black, and then we use white or gray for our data lines in there. So I'm gonna plug this in, and I'm gonna go ahead and power this off just to feel like that's a better way to be safer there. So I'm gonna plug in 5 volts into 5 volts. I'm gonna plug ground into ground. I'm gonna plug the data one into the middle. Okay, so there we go. So now I've got one light, I should say one LED connected to the first channel. Same thing, so the LEDs are addressed in order. Remember, everything when Fast Pinball Land starts with 0. So like the first LED is LED 0, the first channel, first LED, that's got the first 64 LEDs, the next channel has the next 64, the third channel has the next 64, etc., up to 256 maximum. So LEDs number 0 through 63, or the first channel, LEDs 64 to 127, or second channel, etc. Let's turn it on though. So I'm gonna turn power on, and I've got power light is on, my ground light is flashing there. I'm gonna go back to the Mac. I'm running Fusion because I'm gonna show you Windows in a little bit, but for now I'm just gonna say, let's connect to Mac. And then remember, I need to connect to my RGB port now, so I'm gonna go into my options. Oops, it's actually already connected from last time. I'm just gonna disconnect real quick, clear the data, and just show you that I'm connecting to RGB port. So I wanna just make sure that I got the third one on the list, 0, 1, 2, okay, there we go. Okay, connect, and then I'll do an ID to make sure that it's seeing everything. Okay, gosh, what is a command for an LED I can do? I'm gonna do RA colon like 500000. I will tell you in a little bit what that actually means. And look, it's red. You know what? You really can't see that that's red because it's so bright in here. You can kind of see it if I reflect off my hand. Oh, you know what? You probably can't see it if I don't do it like that too. Does it work better on that thing? All right. It's red, if you can sort of tell. And by the way, look at that. Well, let me go back to the Mac. I did RA500. Let's do RA. So what's happening is RA, that's for RGB for all. So this RA command lights up all the LEDs the same color, which I only have one, but that's, I can do. So the first two. So this is in hex, like 2 hex bytes per color. So it's just like HTML colors, like FF is white, 000000 is black, like FF0000 is like bright red. So I'll do that FF0000. I'm gonna go back to the close-up mode before I hit enter, and let's see if we can see it get brighter on here. Yeah, maybe a little bit. Like, oh, you can certainly see it brighter on my hand. While you're looking at that camera, I'm gonna type RA:00FF00. So it's 0 red, all green, 0 blue. Blink. It's green now. I'll do RA:0000FF. So that's 0 red, 0 green, all blue. And now it's blue. RA:00FF00FF. Now it's like kind of purplish. You get the idea here. So again, this is something that you can do, connects to the LED processor, send it an RA command, and just start, like making some lights go. What's interesting about this, let's talk about this. So first of all, I'll go back to the computer. Let me go to the website again. Because like these commands, again, like I was saying, if you're gonna be using Mission Pinball Framework or you're writing your own framework, like you're not probably talking to the board directly over these commands. This is like very kind of low level stuff. This is really good because like just getting started, you're just unboxing and you kind of want to see stuff. But once you sort of, and this is great for testing, right? If you just want to like make sure your LEDs are wired properly or whatever. Really when you're programming your game with MPF or whatever it is you're using, you're not going to be at this level necessarily. But I will say this thing, like these commands I'm sending, ID, CN, like looking at the switches, RA commands, where do you get to know those? This is we call it the FAST serial protocol. So you can go to that FAST pinball documentation site, click on FAST serial protocol, and then read about, here's the basics of how the FAST serial protocol works. Remember I mentioned that like !B02 means that it booted properly, that's in here. There's that CN configured nodes command I was talking about, and so it just kind of explains how the commands work. There's that ID command that we were running, ID:, and then CR. That's like, pushing enter. So there's you can see inside here. So like, for example, if I roll down through here, LEDs, where did they go? Let me get myself out of the way here. So like RA, update all LEDs. And this is where you can see, it's like RA, the red, the green, the blue, and the values. You can update an individual LED with the RS command. So the RS command has the ID of the LED you want to update, and then you give it the colors, and you can actually string multiple ones together. This is kind of cool. There's an RF command that lets you set the fade rate. So, ordinarily, one of the things with LEDs in pinball machines is because LEDs are like so fast to update, like on, off, it's like very abrupt. It's like instantly on, instantly off. And so, but what's cool is you can set the this fade rate so that every time the LEDs get a new command, it'll like soft fade to that new color. So if I go in the computer and do, let's see, let's pull here again. Let's do an RF : I'll do like FF to set like a 255 millisecond fade. And now I'm going to go back to the close-up here, and let's say I'm going to do RA to change it to like, I'll change it to green, 00 FF 00. And watch when I hit enter, it's not going to turn green instantly, it's going to fade to green. Okay, ready? Enter. Oh, that actually didn't work at all. And you know why it didn't work? This is great. If I go back to my Mac here, when I enter that fade command, the RF command right here, you see I got a fail command back, R1: F. It failed. So that means that command didn't work. And so now I can go here into my browser and click the set fade rate and, fade time in milliseconds. Hex? I thought that's what I did, and I thought that should work. Maybe that fade isn't a thing there. All right, what am I doing? I'm doing, let's see, let's go back into here. Okay, RF, like, I don't know. Yeah, okay. Well, maybe that fade is not implemented on this board or this firmware. I guess I'm not gonna worry about that at this moment. So we will see how it goes. What else? Let me show you Windows real fast, okay? So I'm going to power off this board. I'm gonna flip over to my Windows machine. Well, this is a virtual machine. And so let's do a couple things. So I'm gonna now, actually first you're watching the computer here, yep. I'm gonna go to Device Manager. Oops, sorry it's hidden, but there you go. And look at ports, right? So there's COM1, which like always exists in Windows somehow. I'm gonna turn this back on. And then when I turn it on, now I'm running Windows in a virtual machine, which is why the virtual machine VMware Fusion is like, hey, saying, hey, a new device got plugged in, do you want to connect it to the Mac or to Windows? So if it's a regular Windows computer, you wouldn't see that. You would just, I'll say connect to Windows here. And you hear that? Okay, Windows, setting up a device. We are setting up the quad RS232-HS high speed, and you're done. By the way, like, no drivers. That's it. Like, it is installed. And I'm gonna see, why is that showing? There we go, okay. I was wondering why I was like having the little warning sign by it for a second. Maybe I should say that, I shouldn't say no drivers, I should say the drivers that are needed are built into Windows. And so it found those things, it identified them, and it got them installed. And so you saw that they disappeared with a little warning sign, and they now appeared on my ports right here. I'm not a Windows person, as you can tell. I'm a little bit rusty in Windows land. But look, same thing, COM3, COM4, COM5, and COM6. Okay, so now I need to get CoolTerm, which I don't think I have CoolTerm installed here, because I think this is a brand new computer. What is the web browser? Edge? Is that what it's called? Yep. All right. Oh, for goodness sakes. Start without my data. Like literally starting. Oh my gosh. Continue without. Okay, yes. Whatever. Just let's go. Holy moly! Can I start, please? Okay. This. All right. Let me search web. CoolTerm. Okay, CoolTerm download. First result. Actually, this looks like a weird website. Where's the actual guy that made CoolTerm? Here it is, Roger Myers Freeware. Get it from here. That's the guy that wrote it. So let's see, there's CoolTerm there. Download CoolTerm Win. All right, open. There's CoolTerm Win. CoolTerm. Oh, I have to extract everything, oops. All right, downloads, CoolTerm Win, whatever, that's fine. Put it somewhere, obviously, that makes sense for you. I'm just throwing it, kind of wherever temporarily. CoolTerm, like I said, once you start programming with Mission Pinball Framework, you're not gonna necessarily need it on a daily basis, but it's great for troubleshooting. You can connect it directly to the board and see what's happening, etc. So let me run CoolTerm now. Oh, for goodness sake, Defender Smart Screen presented nope, more info, run anyway. Use defaults. Okay, finally CoolTerm is running. Let me close, 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 close. Okay. Device Manager, I'll just minimize for a second. So here's CoolTerm. So remember the first thing we want to go in the options here. And so remember those ports? COM1 we know was not, that was built in. That wasn't one of the ones from the fast board, but it was COM3, 4, 5, and 6, which again, the order, who knows. So I want to connect to that second port, right? Which is the net processor, so it's COM3, that's 4. Remember though for baud rate, 921,600, so it doesn't go that high, but let's do custom 921600. Okay, 8, none, 1 here, that's all cool. I'm gonna go in terminal, and remember, enter key emulation, change that to just carriage return, and also local echo. Local echo is if I don't have local echo and I type characters, the CoolTerm won't show them to me. It won't reflect them back to me. Okay, let me see if I can get fit on the screen. I can't fit the OK button. Nope, you're there. Oh, good gravy. Can I hit enter? Yes. Okay, so I'm gonna connect. It's on, it shows it's connected down here, that's cool. So I do ID, enter, and I'm connected to the net. So I'm gonna disconnect that. I'm gonna click options. I'm gonna go back to my serial port. I'm gonna change to COM5, hit enter. And now I'm gonna click connect. I'm gonna do ID again. And now you see I'm connected to the RGB processor, which is great. And I have this light, let's see, I'll do a RA, let's do FF, very bright white. So bright you can probably see in this little corner window, ready? Hey, you kind of got it. So there we are. That is, that is bright. The camera, it doesn't show it exactly. By the way, I'll do RA:000000, which is like black or off, and there we go. Okay, cool. Yeah, so I think that's it for now. You saw how you can use a terminal emulator to connect. You can connect to the RGB processor separately from the net processor. You can see what node boards are out there. You can get switch information. Understand a little bit how the ports work. I think for troubleshooting, like the main things is just to make sure you have those terminal emulator settings properly, right? If you type in that baud rate, 921,600, if that's not set to that, it's not gonna work. If you have the right port numbers, right? Because again, the ports might change, and it's especially Windows, I mean, it's weird, right? Like sometimes it's ports 3, 4, 5, 6, sometimes it's 4, 5, 6, 7. Sometimes it changes from like day to day, or like if I unplug something or update Windows, it's just kind of weird sometimes. Yeah, I think that's it, really. Oh, I should say, when sometimes it changes, the ports might change if you like plug it into a different, like into a USB hub versus not a hub or whatever. Once you're plugged into that one connection though, they'll stay so that your machine isn't like randomly having new ports all the time. Oh, I know what I want to do. Let's do another RGB thing, but I want to show these strands. So yeah, like these are strands. You can buy these from Amazon, and they come like in a spool like this. But these strands are, if I do close-up view, these strands are actually like made to be connected. Like one goes to the next, goes to the next, goes to the next. So I can plug these in here, and I'm going to plug in. I'm doing it while it's on, so I'll plug in ground first. I'll plug in my voltage, and then I'll plug in my data line. So I can't really get, there we go. Okay, so now I have all of these, and let's do RA:, let's say like 900000, so we should all turn on in red. And there we go. These are really bright red and awesome here in real life. The lighting, all this lighting I have here in the garage set for this stuff, you can see like red against my skin. And that one's on too, because they're all on as red. I'm gonna do RA:000000, just turn them all off. I can also do RS to do single ones. Remember I said that the LEDs on this first port are 0 to 63, then the next one is 64 to 127, etc. So 64 in hex. I'm embarrassed because I need a calculator. That's 40. Is that right? I'm gonna do RF colon 40 to like address the first LED right here. And I'll say like 00 FF 00 to make it green. And I missed because I think oh, you know what? I'm sorry, I did RF. Let's try RS, the actual proper command, 4000 FF 00. I actually got the math right. That's crazy. So I'll do RS 41. I'll do that one 0000 FF. Now the second one, blink, is on blue. And I'll do the third one. Let's do it. If we go back here, you can see I'll do RS colon 42, that next light bulb, and let's do it. Oh, what? FF 00. Let's do it yellow. Blink. And so if I go back to the close-up, you see that one's on now, kind of yellow. So yeah, so this is, you can address these individual LEDs. How do you blink them? How do you fade them? How do you make light shows? That's where your high-level software comes in, right? That's if you're doing Mission Pinball Framework again, or whatever you're using. That's where you're programming your shows and blinking all the lights and all that kind of stuff. But these are the raw commands that are happening under the hood. So again, what's cool is like no matter what happens in your machine, you can always sort of like break into the FAST controller with the serial terminal and look at various commands and that kind of stuff. So I feel good. Wow, we've gone for an hour. I think this like gives you the very much basics. Like at this point, you're probably ready to either start building your like lower third of your playfield, get a piece of plywood, bolt some flippers to it, start to wire things up. Remember again that all the when it comes time to like wiring the machines, if you go back here, let me just go back to that documentation site. I mentioned the tutorials and learning. Click on like wiring guides, and then when you go through, get out of the way here. When you go through here, right, it talks like everything, like how do you do your power line wiring, and like, okay, here's how everything connects. That's like the stuff inside the power box. How do you actually make the connections, all that kind of stuff. Earth ground, but like coils and driver wiring as an example, right? So it's explaining like here's how the boards work, here's how the coils work, here's how everything. So again, I'll make more videos to kind of walk through all this sort of stuff, like step by step. But at this point, you should have your box open, you should have your power connected, you should be able to turn a light on, read a switch, and you're really ready to start playing with MPF, start building a config. You can go to the Mission Pinball, .org website and follow their tutorials, which back in the day I wrote all those myself too. And yeah, just like start using MPF and start building modes and all sorts of things. So I think like that's the unboxing. That is a FAST Nano Controller starter bundle. And hey, reach out for us. All of our customers, you're in our Slack community. You can email me at any time, brian@fastpinball.com. Check out the documentation. Look for the feedback. If you have any questions, please reach out. But we're so excited for the pinball that you're going to build. So like, share what you're building. We love pinball. This is why we do this kind of stuff. And yeah, like make pinball, make friends, have fun. So with that, I really appreciate the time. Happy pinballing. Talk soon.